Welcome to KubeCon Paris 2024. I am here with David G with Synadia, and we're going to talk about something that I'm a little bit confused about because I do clusters all the time, and you're going to talk about a two-node cluster where I'm used to everything being at least three. So, David, let's talk about two-node clusters and how you give reliability with two nodes.
I'm looking at the door now for a quick escape. I'm just going to run two-node. Okay. The first thing I'm going to say is you need to change your thinking a little bit on what you build a three-node cluster for. So let's flip this around. Let's ask you some questions. When you build a cluster and you build three or more nodes or an odd number of nodes, what are you protecting against in your design? Why are you doing that?
Failure, right? In case something breaks and a server dies or more commonly runs out of drive space or something, right? Something goes offline. They need to make sure my users can still access their data.
So another question then, if you were going to build a three-node system, you typically build it in a highly available active, all the nodes, resources that you can then drive, whatever, through the power of YAML and through some scheduling, drive some resources, some containers, stand up some things, some services. Yeah. What about truth?
That's why we wind up with odd numbers, right? That's why in clusterings, I've been doing all sorts of clustering forever, and it's always odd numbers to figure out what the truth is and how to decide what is the truth. And that's always the problem with two, right? How do you know the real source of truth if you've got two that are saying, this is the answer, no, this is the answer.
And who cares about truth?
The system and the end user, so that it doesn't crash, I'd assume.
So truth is an interesting one. So truth, through a lot of experience and research, is always of the eye of the beholder, the application user.
Sure.
So the system doesn't understand truth. It has a consensus of what truth might be, but it doesn't have any context. So it's got meta-truth. If you think about a three-node, it's kind of go, oh, I've got three replicas of the data. At the point of commit, it looked good, but we don't necessarily know what truth is. So then you start talking about two nodes, and every computer scientist worth their weight in salt screams, even from the grave, arms come out and people want to put their, bones and skeletal fingers around my neck and kill me for this. I get it. And I've had many of these conversations. And two-node, what we've done is, if you change the parameters of what you can control, you can change the outcome of the system. So if we say, well, with a two-node system, we know we can't get you a consensus truth. We just can't do it. It's impossible. And we're not going to add shadow nodes. We're not going to add a meta node and this, it's just too hard. And not only that, you imagine a two-node system is supposed to be simple. And if you add all this stuff, you've added massive complexity, more state, more fragility. And I'm going to say something brave, maybe stupid, that once you take layer after layer after layer of open source system and you stack it through the lens of immutability, these systems have been designed to be configured and like doves let go of. And then if the dove goes wrong and mutates, shoot the dove, redeploy. I was going to do the whole cat and pet thing, but I think shooting doves is, it strikes fear into the heart of people. But once we start thinking about two nodes, the things that are their abilities to control things change. There are things we can't do. So there's no point trying to fight it. So we say, all right, we lose the ability to represent a majority of truth. However, the telco industry for decades doesn't necessarily care about that. Because if you think about a pair of firewalls, a stateful pair of firewalls, when you apply configuration to that, and it might be network address translation, it might be rules going through, and I know all the jokes about firewalls. It's a stateful 443 router, I get it. I was in the industry for, too many years. But firewalls have a management plane, they have a control plane, and they've got a data plane. So management plane, we access it, we apply some configuration, the control plane takes that, programs forwarding chips, maybe FPGAs, things that will do processing. But in a mobile network, in a bank, and you've got two load balancers, you have two firewalls, you have two routers on the edge of a network. When one dies, at the point of commit, the configuration was truth. The engineer says, it was truth when I committed, and the system will, at its best effort, take a blob, transmit it to its peer and say, take this. And it says, yeah, I've got it, thanks. And at the point of commit, truth was made. Now, this is exactly the same as three node. You have some data, and the only difference is multiple nodes get the same thing, and they all say, yeah, I've got it. The only difference is now with one node gone, we're in this position where truth is now back in the eye of the beholder of a different system. But if you think about the very nature of what a two-node system is, it's designed to be in remote places, low maintenance, on a vehicle, on an oil rig.
Very edge type devices, right? That's exactly where we start to see this.
Very edge. So this whole thing of long-term durability, we must have truth, is kind of less important. And a lot of these systems are connected upstream somewhere else anyway. So even if we took a 2-node system, we had state, and over time that state would invariably go somewhere else. So if we were generating lots of data, it would probably buffer up locally, and then when the WAN comes online, send it somewhere else. And that system can be highly available, multiple nodes, multiple clouds, multiple regions, availability zones, the whole shebang. But on a 2-node system, what you're using it for is different to a 3-node system anyway. So we kind of went, well, we didn't quite go to hell with truth because you can't. But we kind of said, let's take the telco model. Yeah, because telco model is good enough. Every mobile network on the planet, as far as I'm aware of, uses 2 firewalls, uses 2 load balancers. And it's been the same for decades. I cut my teeth in networking and online gaming. So I ran like networks, Lord of the Rings Online, Arch Lord, millions of players, all this kind of stuff. And the network was 2 mirror images. It's a split mirror image, sorry. So you had 2 load balancers and 2 core routers, and every data center was the same. And never mind all the spanning tree stuff, we won't get into that. So these are like time-proven things. So operationally, you kind of go, yeah, we're happy with truth. We know what truth looks like. So what we've done, and I appreciate I'm taking loads of airtime here to get to this point, but I'm trying to get across, we're not trying to solve the impossible. We're not challenging cat theorem. And all the computer scientists going, well, we don't agree with this. That's fine, because you're focusing on a different problem. Focusing on the problem of edge, not reduced costs for public cloud, where you should be spending money for resiliency and for, truthness. So what we did, we took part in a hackathon last year, so 2023, early 2023. I've not been long with Synadia at all, really. We kind of got involved in this thing. We had kind of 4 or 5 days to come up with an idea, and I realized this was a classic telco problem. It was a problem of system awareness and acceptability of constraints. So I said to my peer, we're not going to write any code. We're just going to literally do a paper exercise and figure out what the logic looks like. And we're going to get to the end of the week. We're going to apologize for not writing any code, and we'll see where it goes. Anyway, we ended the week being asked to write code, and every other team stood down. We're like, oh, we now have a problem. We've got to go off and build this thing. So then we started building this whole system. And some of the tech is proprietary. This is not open source. So what we've done is we've built a 2-node leadership election engine. So that the biggest problem is, because we're not dealing in data replication, the problem therefore becomes a challenge of leadership. Under what conditions should one node lead over the other? And we need determinism for this because of traffic routing, because of stability, because of head-end replication on the data for the control plane and for the data plane. So I doubled down and built a standalone service for 2-node leadership election. So it has a number of sensory kind of inputs. Some of it is external. How does my external world look? Am I healthy? And then it looks at itself. If only more humans did this, we'd be in a very different place. But it kind of says, is my system healthy? Are my services running? And if these things are, happy, and we've got a lot of kind of exit codes that are promising, the system with some confidence says, I am in a position of leadership. And what we do is the binaries are the same. They've got configuration. One node is biased to be a preferred leader, and one node is biased to be a follower. So under normal conditions, if everything's well in the world, the cluster comes up, and you've got 2 machines now in a resource pool, and one takes ownership of configuration, it takes ownership of the API, it takes ownership of state, and it replicates to its peer.
Okay.
And then, let's say the sensors pick up on something's not quite right, it goes into a finite state machine. There's 11,000 lines of code at this point, just in the engine, to figure out what do I need to do. And there are various debounce mechanisms and state transitions. And eventually, let's say some internal failure happens, the node will step down. I'm going to go move to the impaired state. I'm broken. And there are all these different states, right? We start obviously in the init state. We don't know about the world. We have the leader state. So a biased leader, a configured leader will step into leadership mode, and we have a configured follower, and that will step into follower mode. And we have we have 2 more states. An impaired basically means something's wrong outside, something's wrong inside. I'm incapable of being healthy and leading. So then a follower will stand up and take ownership, at which point we have some, again, I don't want to say secret sauce because it sounds like I'm doing marketing stuff. This works, by the way. This is not a paper exercise anymore. We've got some work to stuff. But then the follower will take ownership, and then the resource pool is split in half to 50%. So in a 2-node system, you end up using replica sets. You've got to think carefully about your workloads, which is great, right? Because we're talking about the edge, where things are going to be fairly static, stateless. And the important thing to talk about here is as well that we're not doing anything weird and wonderful with the underlying storage. If you need a SQL database and you need that replicated, you're going to have 2 of them and sort out the replication for configuration level. And what we've taken is we've taken K3S and kine, We did a PR against Kine to replace etcd with NAS. That's open source. You can actually run a multi-node K3S cluster with NAS now.
Oh, cool. So you're actually using NAS as the data stream.
Yeah, I left
Oh,
that right
that's
to the
neat.
last
Yeah,
bit.
dude, that's awesome.
So we got the PR now. Is it perfect? No, but neither is etcd. So I'm not
Okay.
gonna die on that hill. And we're working on it. You know, we know quite a lot now about the intricacies of Kine and K3S and all the various signaling that happens. But yeah, so now you could run a multi-node NAS cluster, which is great. So we take that PR and then we add the TNE code, the two-node engine code or service to it, and we start it up as a separate subroutine. And then there are signals sent. So the TNE system uses NAS as well. So various KV stores and internal pub sub and things like that. So the whole system is based on NAS because why not? It's the easiest way of allowing complex software to communicate internally. And then there is very minimal signaling between those two machines. But if you stand back and look at it, we've got a resource pool of 2. You can run kind of mirror image workloads or replica sets. And you can take a node out, the thing carries on, you plug a node in, the thing recovers. And also a little Easter egg, we also replaced the need for Kubernetes. So we added in the floating IP mechanism. So once the leader steps in, it uses netlink on Linux, and you get your floating IP, and then that moves with leadership. So it's one less component to worry about as well. Now, just for the hell of it and giggles, really, that covers all the problems because once you start using IP tables and NFT to control packet flow from the kernel through the NIC, through the kernel up to the code, you end up with an opaque layer of like, what the hell's going on?
Yeah.
And what I'm a huge fan of is natural systems. So I'm a networking guy, R, neighbor discovery. They're all independent systems. It's not signaled. It's not centrally coordinated. And we've tried to build this in the same way.
Yeah.
So we allow the system to breathe and ebb and flow and debounce and cycle. So it's not crash loop, but this is telco engineering applied to Kubernetes. So yeah, there you go in a nutshell. Hopefully that's interesting. Any questions? Don't know, I've talked and not shut up at this point.
No, that's awesome. And it gave me a much clearer feeling for exactly how it works and how you can still get reliability with just 2 nodes. And I love the fact I hope I'm not saying this wrong, but truth, at least in these cases, truth doesn't matter nearly as much as I was kind of hung up on, I think is one of the key things, right?
And that's, we have to go through this conversation though. When people go, well, what do you care about? Well, we need the system to be online and failure. Well, it is. Oh, okay. So.
But you're right, especially for these types of edge things, it's perfect, right? That's exactly you. Yeah, no, fantastic.
Can I also say there's a lot of thought and effort that's gone into this. We've taken a year to go from whiteboard to working system. So I built the TNE in isolation and I tested this thing. I mean, I've got multiple systems at home where I regularly go up there. I'll have a coffee. I'll pull the power out. I'll pull a networking feed out. They're back on and, plug them all back in and see how it's doing. And that's been incredibly stable for, 12 months. We kind of build it and then been tweaking and optimizing and tweak and optimize. And the closer we've gotten to the use case with K3S and Kine over the top, you begin to realize that you have to invariably add delays into things because Kine and K3S doesn't reconcile as quickly as telco logic that we've applied. So, you think about copying state between different systems, including all the failed state, because it's a crash loop. K3S and, Kine, it's a massive crash loop. It's failed. That generates data. Even the failure data has to go with the positive data. So, in network engineering and software from that space, you focus on the positives, the positive signals. And one thing you take for granted is there is a magnitude set of negative stuff that you have to kind of take on the chin and go, all right, we'll deal with this. So we added extra things and magic sourcing for the integration with K3S and Kine. And some of that is kind of secret source because it's lessons learned. Some of it's hard stuff, but we kind of figured this out. But also things like preemptive recovery. If you think about a mission critical 2-node system, if a node goes offline and comes back in, you don't want the leadership to move because you're going to get service disruption. So you have to leave it where it is. So what we've done is then we built TNE coupled. So the TNE, control system where, maybe out of hours at 3 a.m., you could script the tool to return the cluster back to its desired state. But the question is, do you really care? Because if the temporary leader fails, the other one takes over anyway. So, and if you're running a replica set, you've got the same workloads. Everything that you begin to care about becomes less and less important. Yeah. And we've been on this incredible journey here, and I'm at a point of nerves now because this has been my baby for the last 12 months, and watching it out on the stand here. I was going to say the wrong show name there. KubeCon, not KubeCon EU or the other one we spoke of. It's terrifying and it's so exciting. But because it's simple, we get a huge amount of pushback saying you can't do that, it doesn't work. So having this opportunity to talk about this is brilliant. So thank you.
So I got to tell you one thing that I loved is when you did the introduction, you mentioned the word debounce. And I'm like, where is he going with debounce? And being I'm an electronics nerd, and I do all sorts of Raspberry Pi and everything, and it was just fantastic. Now what you just described, it's like, oh no, dude, debounce is the perfect way to describe that. That's exactly what you're doing. No, that's exciting.
Yeah.
Now, where are you guys in the development cycle? You said this is new. You've been working on it for a little over a year. Is this stuff that you're released and you're already doing for customers? Is this early access?
Yeah. Beta. Yeah. So we're at beta. So we're at a point now where, and I'm just going to probably say some very unpopular things. If Bob or Alice from down the road says, hey, I've got a 2-node Raspberry Pi cluster, I'd love to run it. The answer is probably going to be no.
Yes.
Because Synadia is quite small. SUSE is extremely busy. And what we're looking at is a kind of middle ground of enterprise, maybe a few hundred deployments, thousands of deployments where we can cookie cut and actually get some real world feedback, optimize, tune, and, not figure some more stuff out because that sounds terrible. The final refinements. So we're at a point where we've got to do some more PRs against kine because we have found a significant number of bugs, which we've got to mend. So that's one thing. So we're going to do that. We're going to play good OSS citizens, get those PRs back up there and get that really kind of leveled off. And this goes back to the immutability piece I was talking about earlier on. Systems have been designed to be configured once, go stable, run. And then what happens when you reconfigure? No, we don't do that here. We redeploy. Yeah. But a 2-node system has got some mutability because of the state transitions, and it's not been designed for. So if you think about top down, it's totals all the way down. The system comes online, it deploys some resources, it configures IP tables, it does blah, 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 blah. On a change, nobody's taking care of that.
Yeah.
Bits are, but it largely isn't. So we've got some things to just figure out there because we're not going against the grain. We're just tweaking it a little bit. We think we're in a position where the 2-node is easily understood, but even trying to explain, well, you've got 2 IP addresses. You have a nodal IP address, and then you've got a floating IP address. Yep. Well, where do I put that? Well, it needs to be in the same subnet. What's a subnet? Oh dear. So we're trying to make sure our documentation is up to scratch for those deployments. We want to make an easy deploy. So right now it's a single binary. We literally start up SLE micro, we install the binary, put it on system D, give it some config, and up it comes. And then you want a second node, you build another VM, and I can actually do this on a laptop on an M1 in 10 minutes and bring up a fresh cluster manually.
That is awesome.
And then it works. It's great. But we're in beta just because we don't want to go to market prematurely without receiving that feedback, because these systems, they have to work like electronics. If I started off in electronics. I did an adult apprenticeship in electronics, building embedded systems. Before it was called IoT, before it was cool, before it's called Edge, it was just a processor with assembly, with an LCD, with some sensors, whatever. That stuff works, and it's underappreciated because it's a utility. And we need to get T&E and the K3S 2-node system to the point of utility where you don't even think about it. And right now, I don't think we're quite there. Not from a it's broken and it's terrible perspective, from a confidence and our messaging, and we've got to make some refinements, sure, but we just need the idea to settle a little bit in the community first, I think. Yeah. So anybody interested, obviously come to SUSE, come to Synadia, we can figure something out for sure.
That's awesome, David. Thank you so much for sitting down and telling us all about it.
Thank you very much.